Hi students, this is an English version for the derivation of centripetal acceleration, eventually centripetal force. Well, dear students, you might have gone through many a times the concepts that like a particle is moving into a circular path and it is experiencing an acceleration which is acting towards its center. Well, dear students, uh, generally what we do is that we remember the formula that acceleration, centripetal acceleration, AC is equal to V square upon R, right? Or AC is equal to omega square R, right? You generally, we people say that AC is equal to V square upon R or AC is equal to omega square R. That's true. But here in the Vipinsharma physics channel, I'm going to prove it how it is AC equal to V square upon R and AC is equal to omega square into R. And you know, virtually when you multiply it with the mass, then it becomes centripetal force, MAC, that is FC equal to mv square by R, m omega square by R. So without wasting time, let us start the concept. Expression for centripetal acceleration, correct? Well, dear students, when you talk about the centripetal acceleration, correct, a question comes to the teacher. So why do we call it a centripetal acceleration? Why do we call it a centripetal acceleration, right? So the question is, why do we call it a centripetal acceleration? Because it is a center-seeking acceleration. Because it is a center-seeking acceleration. Now, here we go with the derivation of this. I'll take a particle which is moving into a uniform circular path with uniform speed of v. At every instant, its speed is v. It's not changing. Its speed is constant. You know, when we are here, its speed is v and the time is t1. When we are here at the position v, the time is t2, its speed is v. Now, O is what? Position vector r1. OB is what? Position vector r2. This is v1. This is v2. v1 is velocity at the point A. v2 is the velocity at the point V. Interesting thing is what, students? v1 is equal to v2 is equal to v, means that v1 is equal to v2 is equal to v. Say means suppose r1 is equal to r2 is equal to r. Say, now you will put a question, sir, what is r? That is the radius. What is v? That is the speed. What is r2? That is the position vector of OB. What is r1? That is the position vector of OA. So v1, v2 at the t1 and t2. Hope it is clear. Any question? There should not be any question. So simple it is, right? Now I'm going to use a very important property of vectors that is called sliding vectors. See, this is v1, this is v2. I take this vector v1 parallel, I take this vector v2 parallel, and this is delta v, the change. And the angle traced from t1 to t2 is nothing but delta theta. Delta theta is a very small angle, dear students. It's an extremely small angle. It's very small, a few seconds. In that scenario, delta v will behave like an arc and v1, v2 obviously will behave like a radius. So there is one very famous property that angle is equal to what? that is arc upon radius. Magnitude we will take. Remember, you have to place this modulus. You will never remove modulus. You know, if you remove modulus, then delta V1 is vector, delta V is vector, V1 is vector. Vector division is not possible. It's not defined yet. Now, dear students, I will put a delta V. V1 is equal to V2 is equal to V, say, so let it be V, that is equal to delta theta. So delta V is equal to V into delta theta. Hope it is clear. Now we are dividing delta V with delta T. V delta theta upon delta T. So acceleration is equal to V into omega. Acceleration is equal to V into omega. Now students, I'm going to tell something very interesting. Here you will get an answer why it is called center seeking or centripetal acceleration. See, if I rotate my fingers like this, the thumb comes towards you. If I rotate my fingers towards, thumb comes towards you. Finger is what? The finger is rotating, suppose anti-clockwise. Like it is OA, OB, OC, OD, which is not there. OA, OB like this. Thumb is out. That is the direction of the angular displacement is vertically, perpendicularly out of the plane of this board. And velocity V1 or say V, vector V suppose, is perpendicular. Now, this is what? This is say velocity. This is what? This is what? This is what? This is angular velocity. This is what? Linear velocity. Right? Got it? Now, if we take omega cross V, if we take omega cross V, it is coming out. This is what? This is the angular velocity coming out. This is the linear velocity. Omega cross V. Omega cross V. It is along OA. Omega cross V. It is along OA. This is what? Centripetal acceleration, students. This is called centripetal acceleration. Center seeking. Petal means seeking acceleration. Hope it is clear. So simple it is. This is in the English version I'm telling you. Now omega and V, they are mutually perpendicular. Therefore, AC is what? Omega V sine 90. Magnitude is AC is what? Omega V. V equal to R omega. AC is equal to omega square R. Or AC V equal to R omega, or omega instead we can put V upon R square into R. AC is V square upon R square into R. AC is equal to V square upon R. This is the expression for centripetal acceleration, my dear students. Now, we can convert it into centripetal force as well. How come centripetal force? We are just going to multiply it with the mass. We are just going to multiply it with mass, you know. So here I write, hope it is in frame, centripetal force mass into V square upon R, or it is mr omega square, or omega is equal to 2 pi into frequency. You must be knowing all this formulae. So omega 2 pi nu, right? This is 4 pi square nu square mr. So these are three formulae of centripetal force as well. So dear students, this is an English version of expression for centripetal acceleration and centripetal force. Let us make the best use of technology. Just revise it, rewind it, revise it. Why should I revise now? Let's save the time. So we are on this Vipinsharma physics channel of YouTube, and here I have derived the expression for centripetal acceleration, consequently force. Hope it is clear. Give your comments, and if you like it, share it. Thank you. Have a good day.